Okay, here are the answers. Today's homework, page 73 of your CSEC booklet. Question 1. You're given N is the matrix 4, 2, 3K, and you're told that how N is singular. N is singular. N is singular. So that means that if you were to find the determinant of N, it would be 0. So let's find the determinant of N. The first diagonal would be 4 times k, take away the second diagonal, and the second diagonal is 2 times 3, which is 6. Now if n is singular, we know that the determinant of n is equal to 0. These are your clues. Okay? You have the matrix, n is singular, the determinant must be 0. So if we work out the determinant here, we'll get 4k take away 6. But we know that the determinant is 0. So that means 4k take away 6 is equal to 0. Now remember, once you find yourself in a position where you have only one letter, the rest are numbers, you could rearrange this to work out your answer. So we take the minus 6 and carry it across. We get a positive 6 is equal to 4k. You cross multiply the 4 underneath, you end up with 6 over 4 is equal to k. We can reduce the 6 over 4 to be 3 over 2 is equal to k. 3 over 2 is 1.5. 1.5 is equal to k. Therefore, k is 1.5. Ta-da! Let's move on to question 2. Our recording. Question 2. We're given Z is a matrix 3, 5p, 15 and p to the power 3. 15 and p to the power 3. Write down the determinant of Z. Part A. The determinant of Z would be the first diagonal, which is 3 times p raised to the power 3. Take away 15 times 5 is 75. 75p. Calculate the values of p which make the matrix Z singular. So we have B here. If Z is singular, then this is equal to 0. Let's go here now and say, let's continue from A. From A, we know that this is equal to 3p cubed minus 75p. And since the determinant is 0, because Z is singular, we have 0 is equal to 3p cubed. Remember, that is 0, that is 0. So we can replace that with 0 minus 75p. Okay, remember, the question is asking you to calculate the values of p. Remember, once you find yourself in a position where there's an equation with only one letter, you can solve it. To do this now, we're going to have to factorize. And if we factorize here, both numbers we're going to factorize here. We get 3p on the outside, if you remember how to factorize. 3p times what gives you p to the power 3. 3p multiplied by this will give you p to the power 3. Take away, and 75 divided by 3 is 25. 25. Okay, look at that now. Double checking if this is correct. This times that should give you this. This times that should give you back that. Okay, now this means here, therefore 3p is equal to 0. If 3p is equal to 0, cross multiply the 3. P is equal to 0 over the 3, and p is equal to 0. Check your calculator, you'll see that. That makes sense. 3 times 0 gives you 0. So this is one correct answer. However, you have also this here could be 0. So it's either this piece is equal to 0, that, or this here is equal to 0. So let's go work with that now. And p squared minus 25 is equal to 0. As that here is equal to 0. Remember to factorize using the difference of two squares. You'll have p plus 5, p minus 5 is equal to 0. And this means, therefore, p plus 5 is equal to 0, where p is equal to minus 5. That's one answer. And you also got p minus 5 is equal to 0. So when things are being times to give you 0, one of those things that are being times could be 0, or the other thing that is being times could be 0. So this could be 0, or that could be 0. If that is 0, we come down here. If that is 0, we come down here. P is equal to positive 5. Those are your answers. 3 different answers. 0, minus 5, and 5. Question 3. Given that m is equal to 3b1a. 3b1a. Calculate the determinant of m. Part A. Find the determinant of m. 3a minus b. Calculate a pair of values of a and b such that m is singular. So we are finding values for a and b when that is 0. That means when m is singular. Okay, so let's go. When m, the determinant is 0, we have now, therefore, 0 is equal to 3a minus b. Let's work this out. Calculate the values of a pair of values of a and b such that m is singular. So we get, carry the minus b across, we have b is equal to 3a. So we need a pair of values of a and b. So let's just say if b is equal to 1, then, or I should say, if a equal 1, what you'll get b equal to. If a was equal to 1, then b would be equal to, let's substitute it here, b is equal to 3a, b is equal to 3 times 1, b is equal to 3. See? So if a is equal to 1, then b is equal to 3. Since b is equal to 3 times a is substituted as 1, it will work out to be equal to 3. So that is a pair of values of a and b. You could have used any number here. You could have used 1, or you could have substituted with 2 and work out what answer you get, or 3, or 4, 100, 394, any number you want here, and then you work out what b is, and as long as you did that correctly, you get your full marks. Okay. Question 4. Question 4. T is a matrix. T is equal to 2q 0 and a p here and a p there. Alright. State the determinant of t. The determinant of t would be 2qp minus 0 times p, but 0 times p will give you 0, so that will give you 2qp, take away 0, which is 2qp. Now, part B. If q is a half and p is 4, determine the inverse of t. Determine t inverse. Let's go ahead. Let's first find out what is the determinant of t. 2qp. Now let's replace q with a half and p with 4. 2 times a half is 1. 1 times 4 is 4. So the determinant of t is 4. So t inverse is equal to 1 over 4. And now we have to find the adjoint matrix of t, which would be p 2q and keep the 0 here and minus p. We swap the p here and then we change the signs. The sign of 0 will change, would remain 0 anyhow, and this will change to negative p. So that's it, except that we know the numbers for p and q. What are the numbers? A quarter times p is 4. So we have 4, 0, minus p will be minus 4, and 2q. If q is a half, then 2 q's would be 1. And this here, you can work it out further, is equal to a quarter times 4 is 1, a quarter times 0 is 0, quarter times minus 4 is minus 1, a quarter times 1 is a quarter. That is your answer. So I've done up to question 4 for you, and that's it